Here's an explanation for the answer to final exam question number 47 in Electronics Demystified, 2nd edition. If you have the printed book, please see page 427. In theory, we can demodulate an FM signal using which of the following four methods? A, an AM receiver and slope detection. Well, yes, that will work. And here is an illustration of how that is done. This curve that you see right here is the frequency response curve of a typical AM radio receiver. Notice the deviation going negatively and positively from the channel center in kilohertz. About 6 kilohertz either way, encompasses the entire response curve of the AM passband. Well, if we try to receive an FM signal with this kind of a response curve, we can do it only if we tune the FM carrier, the unmodulated carrier frequency, just about midway between the middle and one side of the response curve. So somewhere along this straight line portion right here, if we put the FM carrier frequency, that's that dashed line there, if we put that frequency right there, then the FM signal, as it makes its excursions, plus and minus, will go up and down along this slope, and that is why we call this slope detection. We'll get more output when the frequency is at this part of the curve and less output when the frequency is here. Now actually, a typical FM signal plus or minus 5 kilohertz would make excursions into the nonlinear part of this response curve, so that slope detection is going to give us, in many instances, a good deal of audio distortion in the output. But we can, in theory, demodulate an FM signal this way. That I just thought that I would show you this illustration because it's easy to, well, it's just kind of a cool technique, even though it's cheating a little bit. This is the response curve intended for amplitude modulated signals. AM, not FM, but we can receive FM if we tune the carrier along. Now we could also put the carrier over on this other side so that it would make excursions, say, roughly in that part of the curve. So choice A will work. Choices B, C, and D, all three of those choices are also valid ways to demodulate an FM signal. So the answer to this particular question is E, all of the above. You can go back and look at the FM demodulation techniques starting on page 313 of the printed book, page 313 if you have the printed book, or chapter 10 if you're using the electronic version where the page numbers are not really so well indicated. That discusses detection of FM. You can also refer back to figure 10-5 A and B on page 311. And also the diagram of a ratio detector circuit is shown on page 314, but they're all in chapter 10 under the main header of detectors. So once again, the correct answer to this question is E. In theory, we can demodulate an FM signal using any of the techniques outlined here.